In Learning Objective 3.9, I'm going to talk about what a z-score is, show you how to find it, and how to interpret it. So what it is the number of standard deviations that a piece of data is from the mean. Here's the calculation right here. What it says is you take your x value, or your piece of data, minus the mean over the standard deviation. So for example, if you had a test score, maybe you got a 30 on a class test, you would put your test score here. If the class average was 28, you'd put it there, and you'd get the standard deviation from the mean and put it there to get your z-score. If we think about calculating it that way, what would happen if it's a positive z-score would mean that you put your test score in here minus the mean. If your test score is higher than the mean, the answer is going to be positive. So if the z-score is positive, then the data is above the mean. What if I got a test score of 25 points? Well, I take 25 minus the 28, that's going to give me a minus 3 on the top. So that tells me that a negative z-score then is the data below the mean. Now for vocab, raw data or scores, no just means it's the original data. If they ask you for standardized data or the scores, all they mean is this transformed data. And the transformed data is finding a z-score. So if someone says transform the data, they just mean, again, take your piece of data minus the mean over the standard deviation. So let's talk about what it means. Nancy here scored an 87 on a math quiz. The mean of the class was 70. The standard deviation was 8, which means on average, if I randomly chose a student, they'd be 8 points above or below the mean. Find her z-score. Easy enough. Her score of 87 minus 70 over 8. Just do your order of operations correctly. You must do 17 on the top and over 8. Then you're going to get 2.125. What that means is you would say Nancy scored 2.125 standard deviations. You have to talk about the direction on this, above the mean. I know it's above the mean because her z-score came back as a positive value. And think about it, 87 points, the mean of 70, clearly she's above it. Now, just to give you an understanding where this z-score even comes from and why it's in the chapter is this. Here's the formula again, piece of data minus the mean over standard deviation. This component here, taking the piece of data minus the mean, that is just considered to be a translation of the data, which we talked about in section 3. When they do this component where they divide by a value, this is a scale change of the data, which we talked about in section 6. Well, section 7, we just talked about function composition. So what they do is they do S of t of x, or the scale change of the translation. When you do that, if you take the translation and you embed it in the scale change, what you end up getting is the actual z-score calculation. One of the things about the z-scores is, notice this. Let's say that we were going to take this test data in list 1. If these are all the scores of some tests of students in my class, let's say I'm going to take everyone's test score and do a translation of 70 points. So the class mean was 70. So here's what you're going to notice. The person that scored 60, I subtract 70 minus 10 below the class. Person at 68 is 2 points below the class. Person at 73 is 3 points above the class. Okay, now let's go ahead and do the scale change. If the standard deviation is 5, I'm going to take their score minus the mean of here negative 10, divide it by 5, negative 2. This person here at 73, again they were 3 points above the mean. If I divide that by 5, it's 0.6. So what we have here in list 3 are all of the z-scores. Now, if I were to take the mean of all of these z-scores, so add them up and divide by how many there are, here's the clever thing. The mean of all the z-scores is 0. the standard deviation of all the z-scores will come back to be 1. This is a very important property of the z-scores, and what it does is it allows us, if we have the same group of students taking a math test and a science test, I could compute z-scores for both exams, and they could be comparable to each other, even though they're completely different subjects.